Namaste. This is JB and Dr. Vishal Saxena, Associate Professor in Mathematics and Statistics in Jayoti Vidyapeeth, Women's University, Jaipur. Today I am going to discuss about the module measure of central tendency, and we are discussing about the part median today. So first we see what is meaning of median, measure of central tendency, and we take the part as a median part today. So median is a centrally located value of a series such that half of the values or the items of the series are above it and the other half below it. So median is a part of the central tendency, and as all we know that it must be a central value. So it is a centrally located value of a series such that half of the values of the items of the series are above it, and the rest values means the half other values will be below it. We can understand here by the another definition of median, and we take as median is the central value of the variable that divide the series into two equal parts in such a way that half of the items lie above the value and the remaining half lie below the value. Median is defined as the value of the middle item or the mean of the values of the two middle terms. It is applicable for the number of data when the number of data are in even values. When the data are arranged in ascending or descending order of magnitude. So it is very important to find median. First, we have to arrange the data in ascending, in either ascending order or the descending order. And then we have to apply the formula, we have to apply the method by which we can calculate the series or the median. To find median, the data should be arranged first in order of least to greatest or the greatest to least value. That means the data must be arranged in either ascending order or descending order of magnitude. A median is a number that is separated by the higher half of a data sample, a population or a probability distribution from the lower half. The median is different for the different types of distribution. So the median is different for different types of distribution. It is important point that the median is different for different types of distribution. But it is very important to find median that the first we have to arrange the data in ascending or the descending order of magnitude. Now a diagram is shown that in which median is shown, and median is representing by the pink bar, while the other bars, other buildings are given by the green color. So we can observe that the median is the middlemost value of the data, and where 50% below values are there and 50% above from this median are shown in the figure. So in this way, median is a central value of the data when the data are arranged in ascending order or descending order, and it will be the middlemost value of the data. Now next we discuss about the methods to find the median. So we know there are three types of statistical series. One is individual series, second is discrete series, and third is continuous series. So individual, discrete, and the continuous series, all we know that three kind of series exist in statistics, and for which we have to calculate the median part. So there are different methods to calculate median for the different series. Like first, when we take the individual series, the median of individual data set is dependent on whether the number of elements in the data set is odd or even. So uh, when we discuss about the individual series, the first we should know here what are the number of data that is odd or even. So first reorder the data set from smallest to the largest. That is either ascending series or the descending series. So in general, we arrange the data in ascending order and in ascending order. So when we take the data in ascending order, so we have to apply the formula, different formulas to find median. So first we take the formula for the odd series and the formula for the median is given by n plus 1 upon 2th item. The formula is given by n plus 1 upon 2th item. And for the even series, the formula of median is given by average of n upon 2th item plus n upon 2 plus 1th item. So there are two different formulas for the odd series and even series in the case of individual series. So we have to now we have to learn these formulas to apply for questions or the examples, and n represents the total number of data. Now we take examples. We take example. So odd number of elements. Suppose we are given that in this example, the data sets are given that 2, 6, 9, 3, 5, 4, 7. So these are the values of data sets like 2, 6, 9, 3, 5, 4, and 7. And we have to find the median. So this is clear from this series that the series in the individual form, because the frequencies of the data are not given that. So first we have to count for the data. How many data we have? We have the 7 data. So 7 data. So it means the number of data are 7, and which is an odd value. So we have to apply the formula for the odd value. And in this case, the median is given by 7 n plus 1 upon 2th item. So the formula for the odd number of data is given by n plus 1 upon 2th item, and n is equal to 7. But before this, we have to write always a series in the case of median, that is in the ascending order. So the given series is 2, 6, 9, 3, 5, 4, and 7 is rewritten in this way, like 2, comma 3, comma 4, comma 5, 6, 7, and 9. So this is the series written in ascending order, and median is given by n plus 1 upon 2th item. So n is 7. So 7 plus 1 upon 2th item, that is 4th item, and which is equal to 5. So the series, the median is equal to 5. Now next we take example. In this example, we are given that a data set like 2, comma 6, 3, 2, comma 6, 9, 3, 5, and 4. 2, comma 6, comma 9, comma 3, comma 5, and 4. And we have to find the median. So first we have to arrange the data in ascending order. So the ascending order of the data are 2, comma 3, comma 4, comma 5, comma 6, comma 9. So this is an ascending order of the data 2, 3, 4, 5, 6, 9. And we can observe the total number of data are 6. The total number of data are 6. And in this case, the median is given by The median is given by the formula like n upon 2x data plus n upon 2 plus 1x data and whole divided by 2. So n upon 2x data plus n upon 2 plus 1x data upon 2 is the formula, and where n is equal to 3. So in this way the formula reduces to third item plus fourth item value upon 2. Third item value plus fourth item value upon 2, and which is equal to 4 plus 5 upon 2. So 4 plus 5 upon 2, these are the values 4 and 5 taken from the series, and after calculation this becomes 4.5. So this is the 4.5 is the value of median, and the question is for the individual series and for the even number of data. Now we take one more example. The question is find the median of the following series: 4, 17, 77, 25, 22, 23, 92, 82, 40, 24, 14, 12, 67, 23, and 29. So these are the values of data, and the question is to find the median. So first of all, when we put those numbers in the order we have in ascending order, first we have to make the ascending orders of the data. So that is 4, 12, 14, 17, 22, 23, again 23, 24, 25, 29, 40, 67, 77, 82, and 92. So these are the data written in ascending order, and there are 15 numbers. So these are the 15 numbers. Our middle is the 8th number. So it means if 15 numbers are there and this is an odd value, and the question is from the individual series because the data are given that frequencies are not given, and the total number of data 15, which is an odd value. So we have to apply the question for the formula of odd number. So the median is equal, the median for the odd number of data is given by n plus 1 upon 2th item, n plus 1 upon 2th item, and this is given by 24. This is given by 24. Now next example we take Rahul's family drove through 7 states on a summer vacation. The prices of the gasoline differ from state to state. Calculate the median of gasoline cost. So in this question we are given that the prices of the gasoline differ from state to state, and calculate the median of gasoline cost. So we are given that a table for the 7 states, and the prices of gasoline are given for the 7 states like 1.79, 1.61, 2.09, 1.84, 1.96, 2.11, 1.75, and we have to find the median. So by organizing the data from smallest to greatest, we get, so first we have to arrange the data in ascending order like 1.61, 1.75, 1.79, 1.84, 1.96, 2.09, and 2.11. As we can see, the total number of data are in this question 7. So 7, there are 7 data in this question, and the series can be taken as the individual series, and the number of data is 7, and 7 is an odd value. So for the odd value, the median is given by n plus 1 upon 2th data, n plus 1 upon 2th data. So n is given by 7. So 7 plus 1, just 7 plus 1 upon 2 means 4th data, four data from the ascending order series. So it should be 1.84. 1.84 is the value of median in this question. Now next is the discrete series. The discrete series is also known as the ungrouped data, and the median of a discrete data set is dependent on whether the number of elements in the data set is odd or even. And first reorder the data set from the smallest to the largest, that is ascending order or maybe descending order. So in this case of discrete series or the ungrouped data, the median can be calculated by again formula for odd number of data and for even number of data. So depends upon the total number of terms whether they are even or odd. And for this, first we have to arrange the data set in ascending order or descending order. Now we take the formula for the odd series or the even series. For the odd series, the median is given by size of n plus 1 upon 2th item, size of n plus 1 upon 2th item, and for the even series, median is equal to average of size of n upon 2th item plus size of n upon 2 plus 1th item. So these are the formulas to find median in case of odd series and the even series. So for the odd series, the formula is given by n plus 1 upon 2th item, where n represents the total number of data, while for the even series, the median is given by average of size of average means divided by 2. So size of n upon 2th item plus size of n upon 2 plus 1th item. Now we take example for this. So from the following data, calculate median. Now in this question, marks are given that and number of students are given that. So marks and the number of students are given that. So this is the question from the discrete series. Marks can be taken as the values of x and the number of students can be taken as the frequencies. Now in the solution part, we take the marks in ascending order. So first we have to write the ascending order of data, and this one is like 5, 15, 25, 35, 45, 55. So these are the data in ascending order: 5, 15, 25, 35, 45, and 55. While the number of students F frequencies are 10, 20, 30, 50, 40, 30. So these are the frequencies corresponding to such data X. And now we find the cumulative frequency. The cumulative frequency are given by 10, 30, 60, 110, 150, 180, and where n is equal to 180. So total number of data are 180 in this question. So n is equal to 180 and even value. If it is even value, then median is given by the formula size of n upon 2th item plus size of n upon 2 plus 1th item. So size of n upon 2th item plus size of n upon 2 plus 1th item and divided by 2. So this is given by size of the 90th item plus size of 91st item divided by 2. So this is the question from median, and just we can calculate the size of 90th item plus size of 91st item as because we have to see 90th item, so we have to see 90 in the cumulative frequency table, and in the cumulative frequency table 90 is not present. So we have to see just above data then 90 in the cumulative frequency term, in the cumulative frequency column. So that is 110. 110 is the just higher value of cumulative frequency than 90, and corresponding to the value of x is 35. So 35 is the size of the such data. So size of 90th item is 35, and in the similar way the size of the 91st item is again by the same procedure is 35. So it means 35 plus 35 upon 2, and therefore median is given by 35. Median is given by 35. So this is the method by which we have calculated the median in the case of the discrete series or the ungrouped data. Next is continuous series. The third kind of series is known as continuous series, and for this we have to find the median. In the case of group data or the continuous series, the median is given by m is equal to L plus n upon 2 minus PCF upon F into I. So this is formula L plus n upon 2 minus PCF upon F into I, where L shows the lower limit of median class interval. Lower limit of median class interval is L. PCF shows the previous cumulative frequency of median class. So PCF is the previous cumulative frequency of median class. F shows the frequency of median class. F shows the frequency of median class. I shows the size of median class, and N represents the total number of observations. Now we take example for this. X is the median of the series 4, 3, 8, x and 7. Then find the possible values for x. So the question is, if x is the median for the values 4, 3 and 8, x and 7, find the possible values for x. So according to question, arrange the numbers in ascending order with x in the middle. So we are taking, because we are given that the x is the median, so x should be placed in the center of the series, and the series can be written as 3, 4, x, 7, 8. So this is the series, and this tells us that the possible values of x are 4, 5, 6 and 7. Now we take example for this. From the following data, calculate median. So for this series, we have to find the median, and median is given by, in this case, actually the question is from the continuous series or the group data. So we are given that marks in class interval form, and the number of students, the frequency. So first we have to make the cumulative frequency table for this question to find median. And median is given, just the cumulative frequency table is made there. So marks in the first column, and these are x, number of strands, that is the frequency f shown in the second column, and cumulative frequencies are made in the third column, like 10, 30, 60, 110, 150 and 180. Next is size of n upon 2th item. Then we have to find the size of n upon 2th item. So n is equal to 1 upon 180. So this is equal to size of 180 upon 2th item, 180 upon 2th item, and that is equal to 90th item. So size of the 90th item And next step is cum- uh, commutative cumulative frequency, which includes 90th item is 110. So just we have to see again the table, and we have to find the size of the 90th item. So because 90 is not present in the cumulative frequency column, so just bigger value than 90 is 110, and corresponding to 110, the class interval is 30 to 40. So 30 to 40 is called the median class interval, where L is equal to here 30, the lower limit of median class interval. 50 is the value of frequency of median class interval, and H is given by 10. H means the width of the class interval, which is 10, and PCF, the cumulative frequency just preceding the median class interval is 30, is 60, because 30 to 40 is the median class interval, and its previous class interval is 20 to 30, and 60 is the cumulative frequency of just preceding class interval of median class interval. So we have shown in this table like 30 to 40 is the median class interval, and L is equal to 30, the lower limit of median class interval. 50 is the value of F frequency. 60 is the value of FPCF, and this is the median class interval. So now we apply the following formula to find the median. M is equal to L plus N upon 2 minus PCF upon F into I. So L is given that 30, the lower limit of median class interval. N upon 2 means N is given by here 90. N upon 2 is 90, and minus PCF, the value of PCF, preceding class cumulative frequency. So preceding cumulative frequency is 60 there, and upon F, F means 50, the frequency of median class interval, which is 50, and I is the width of the class interval. It may be H or it may be I. We can write whatever the notation. So I is here 10, and by solving this, we will get the median as 36. So median becomes 36 for this question, and this is the question from the group series, group data. So in this way, today we have discussed about the topic median, and median is a part of the measure of central tendency, and it is very important part, median. And just median, we have defined it initially. This is the middlemost value of the data, and where data are arranged in either ascending or the descending order of magnitude. So we have found the median in different cases for the different series, like for the individual series, uh, for the discrete series or the ungrouped data, or for the group data. So we have calculated the median in all three type of series, and with example. So with this, I conclude today's lecture. Thank you.